So you're looking at the remains of a new genus and species of dinosaur, the most complete skeleton ever found of a supermassive animal. And in life, fleshed out, this would have weighed 65 tons. And to put that in perspective, a full-grown bull African elephant weighs about 5 tons. So you're looking at an animal that is equivalent to a dozen giant elephants smooshed into one body. So everything about this dinosaur is giant. The femur is 6 feet tall. The upper arm bone, the humerus, is almost as tall as I am. The tail bones are gargantuan with huge muscle scars that show us that it essentially had a weaponized tail that was 30 feet long. One vertebra in the neck is over a yard across. So this incredibly large and muscled individual that would have feared nothing in its landscape. That evokes, to me, this class of turn of the last century battleship called the Dreadnoughts, which were huge, thickly clad and impervious. And as a result, I've decided to name this dinosaur Drednautus, or fears nothing. I think it's finally time that herbivores get their due. Other very large dinosaurs like this are generally known from only a couple of bones. In many cases, 1, 2, 3 bones, and this one is represented by over 100 elements. And so for the first time, paleontologists are going to have a look at a nearly complete skeleton of one of the most massive creatures that ever walked the earth. So there are a lot of good places to look for dinosaurs in the world, and one of the best is Patagonia, and southernmost Patagonia has received relatively little attention. So I wanted to go there because I figured I would find some dinosaurs, and because it's relatively unexplored, I thought there was a good chance that there might be something new. So this is the discovery piece. This is the giant femur of this animal, and in 2005 I found a small patch of this bone exposed at the surface. It was hard to recognize that bone. It had been covered by gypsum minerals and weathered. And so I GPSed this bone, and we came back later that day. Began to uncover this, and eventually uncovered hundreds of bones representing the skeleton at this site. So one of the most amazing parts of this dinosaur is its tail. And the tail starts here, and it goes way down to here, and then it would go about 8 feet through this wall. And so it's 30 feet altogether. And this is an incredibly bulky, massively muscled tail. Everything about this speaks to its power. And this is a really interesting set of bones. We call these chevrons. And in other big dinosaurs, this area kind of comes down and tapers to a gentle V here. In this dinosaur, it flares out into this immense area for muscle attachment, making this, I would say, the most powerful tail that's ever been seen. One of the most enjoyable aspects of this project has been working with my Argentinian colleagues. Back in the lab here, though, we're starting to apply some very cutting-edge techniques to studying this dinosaur. We're using a 3D laser scanner to capture the digital form of these bones, and then essentially we can digitally curate the fossil. This has the advantage that it doesn't take space. These images can be ported around the world to other scientists, other museums, and we can use them in biomechanical models. A dinosaur in this mass range, 65 tons, is really pushing the limit. So what is physiologically possible? So it'd be very hard to understand this dinosaur from a very fragmentary skeleton, and we're fortunate that we have nearly a complete skeleton of this amazing creature. So we're going to be able to understand kind of the frontier of physiology in terms of supermassive land animals from this animal.